Hi everyone. Welcome to BI in 10 minutes, where we try to get to the point about a single business intelligence concept. In this episode, I want to talk about why Power BI performance tuning is such a pain in the butt. And I think there's four main reasons to consider. The first is that performance isn't an issue until it is. And what I mean by that is, at least whenever I work with Power BI or I work with customers, it tends to be something that there's either self-service or an iterative design approach going on. And so what that ends up meaning is that the design tends to start small. And over time, it gets bigger and bigger and bigger in a number of different ways. So one, you may be focused on just 1 year of data, and that might expand to 3 years or 5 years or 10 years. Or you may have a few measures that are defined and you keep adding more and more and more. Or the scope may increase because of the logic required. I had a customer once where they wanted to be able to view 3 or 4 different measures all within the same measure. And so we added more and more layers of if-then logic so they could change what the currency was, or they could change what the output was. And at least at the time, the way that we did that moved it from using the storage engine to the formula engine in DAX. And that made performance tank. And so what you can run into is something where everything is fine up to a point until people start complaining. It may also be that you are adding new users to a report. And what may have been acceptable performance for a certain subset of users or a certain subset of needs changes, and now it suddenly needs fixed. So that's the first issue, is that business intelligence in general, but especially Power BI report design, is an iterative process. And it's very easy to start with good performance, either on a subset of the data or with a smaller scope, and then you add one more thing, and it's the straw that breaks the camel's back. And now you're having to backtrack and figure out, okay, well, how do we think about performance? And if you haven't designed with it in mind from the beginning, it can be a lot of work. The second issue is that Power BI is a polyglot tool. That is to say, it involves a lot of programming languages. Specifically, you've got DAX for your measures and your design. You've got M for your data cleansing. And a lot of times you've got SQL for backend. And unfortunately, it is a big request to ask people to become experts in 3 different languages. Especially because a lot of the times they don't need to. They don't even need to be good in a lot of those languages. I don't think that you can write efficient and effective reports without getting pretty good at DAX, but M and Power Query are good at query folding, so it can push a lot of the work back down to SQL. And in terms of SQL, usually you're doing import, you're pulling stuff in overnight. And so in those cases, performance doesn't matter until you're hitting that refresh window. But again, things change. It may be that you've eclipsed that refresh window and suddenly 2 hours isn't enough. It may be that you've decided to use direct query and suddenly refresh performance and rendering performance are the same thing, or at least they're connected. And so you'll see people that talk about performance tuning with Power BI, but a lot of times it's very focused on a particular thing. And so it's hard to tell when your car, so to speak, is making that cha-chunk, cha-chunk noise. Is it a problem with the engine, the transmission, the muffler, what? And that brings me to the next point. Point number 3 is that Power BI is also a multi-engine tool on multiple different levels, right? So again, at a very high level, you've got the Vertipack engine for DAX, you've got the Power Query engine for Power Query and M, and you've got the SQL engine for the SQL backend. But even within those, you've got different components. So for the Vertipack engine, you've got the formula engine and the storage engine. For SQL, you've got a lot of different sub-components that you have to consider. And the problem is that each of these different engines requires different mental models and functions wildly differently. And so one of the things, for example, is that SQL is traditionally a row store engine DAX is a column store engine. And so how it stores data and how you access it is very different. You have completely different understandings of internals that you need to have. Or another example is that M is a lazy language. It'll only evaluate things when it needs to. And generally it's written in a very linear sort of thing. So we're expecting people to learn these engines and languages where one is formula based, one is procedural with all these steps, and one is set based. That is a lot of internals that we expect people to know in a situation where, again, most of the time, performance isn't an issue. Power BI, thanks to Microsoft, has a huge number of default optimizations that for small reports provide amazing performance right out of the box, right? The issue here is that Power BI is too good most of the time, unlike, say, SQL, where you always have to be thinking about performance. Power BI is too good most of the time until it suddenly isn't. And now you're having to kind of work from the ground up to figure out what you need to do. And so that's kind of the challenge. So in the DAX engine, VertiPack, you have multiple different ways of compressing and encoding data so that it's super fast. And the data is stored in memory, so it's super fast. And if you even approach a star schema, most of the times you're going to get those benefits. Again, with Power Query and M, query folding is really, really effective. And so most of the time, if you just clicky, draggy through the UI, you'll get queries that are good enough in a lot of circumstances. And so it's this sort of thing where there's not a need to have an engineering mindset. There's not a need to be thinking about performance tuning from the very beginning until, again, you run into a problem and you're realizing, oh, I've built this model on a house of cards and now I have to rebuild something more structurally sound. And finally, the fourth reason, in my opinion, that performance tuning is a pain in the butt is external tools are a must if you want to get good at this. The way that I describe it to my peers in the SQL Server world is, imagine instead of having almost everything you need in SQL Server Management Studio, you had to install Sentry, Query Explorer, Plan Explorer, or all these other add-ins. Well, it's the same thing in the Power BI world. Now, they've added Performance Analyzer for DAX, which is a lifesaver, but I still use DAX Studio regularly, right? And if you want to be looking at SQL performance, well, now you're going to have to look at extended events, query execution plans, potentially Profiler if you're talking to SQL Server Analysis services. And then there's a bunch of other tools. Tabular Editor is on my list to learn. I've heard a lot of great things. But in general, if you're trying to do performance tuning entirely within the base Power BI ecosystem, so Power BI Desktop, it's going to be a very difficult and frustrating situation. And so I think the solution here is trying to help folks get a landscape of where all the problems could be. If I hear that cha-chunk noise with my car, where could it be? And then how do I debug that issue? Because again, people who are used to Excel and coming from that background or more of a business world background aren't steeped in performance tuning as part of what they do. Whereas if you were a SQL DBA and you're coming over, this is a regular part of the work that you do. So it's not an easy problem to solve, but there's reasons why it's so difficult.